Good morning, everyone. This is Shauna, and I'm coming to you right now with a walkthrough for section 3.4, exploratory data analysis. This was requested by one of your classmates, and I know that the previous walkthroughs have been helpful. I'm hoping that this will be no exception to that. So let me at this time share my screen, and we'll start with some of the slides for this homework. In this section, it's called exploratory data analysis. We're going to be focusing on the box and whisker plot. And to draw the box and whisker plot, it requires 5 data values from your data set that we've used already: the minimum value, the first quartile, the second quartile, the third quartile. So basically your quartiles that you're used to, and the maximum. So once again, the minimum, the 3 quartiles, and the maximum. Together, these are 5 values that are called the 5-number summary. Sometimes these values will repeat, but usually they're distinct, okay? Depending on how your data works. Now, on the next slide is how to get the 5-number summary given data, which I'm going to show you how to do. And then there's a whole procedure for actually constructing a box and whisker plot, which this is how you actually draw the rectangle. And sometimes we have whiskers. Sometimes you have whiskers. Sometimes you may not. Sometimes you may just have the edge of the rectangle. But normally, you'll have whiskers on either end. They may not be the same length. And you'll have a line in the middle that defines where the median is. That may or may not be in the middle of the box. If it's a skewed distribution, either positively or negatively, your median will be on one side of the box or the other, and the center of the box, called the mid quartile, will be in the center. And we'll talk about that when we get there. Let me now switch my screen share here to the homework assignment itself. Okay. Now it says for exercises 1 to 3, identify the 5-number summary and find the interquartile range. Okay. So let me do something here. Let me bring up the calculator emulator. Let me stop sharing temporarily. Bring up the calculator here for us so I can show you this. Okay, allow it to open. Bear with me for a moment, folks. Okay, let me do some housekeeping for a second. Let me go here. Okay. Actually, well, I'll do it again. Second. Second. No. Clear enter. Okay, now we're ready. Let me share screen one more time. Here. Let me go back to Zoom and share screen. Now I'm looking at this data. Now, usually if you have raw data like this, you want to sort it. If it's not sorted, she has sorted some of this data for you, not all of it, but these 3 are not sorted. So what we're going to do is, if you were going to do this by hand, you'd want to sort this data. So I'm going to put in the data values for number 1 here. So I'm going to take a moment on a paper next to me and write down these values: 8, 12, 32, 6, 27, 19, and 54. Okay, so I'm going to take a moment here and do this. Now I'm going to bring up the calculator at this time. So let me bring that into our picture. All right, so here's, oops, going to, not sure you're seeing what you're supposed to. There we go. All right, now you should be seeing the calculator. And we have our data. So I'm going to begin by putting in my data as I have in other videos. There's other videos where I show you how to do this, but essentially what we're going to do is we're going to be on our, so let me come back to where I was. Here's my home screen. And if you turned it on in your home screen, you may have data on your home screen, but or not. I'm going to go to stat. I'm going to begin by putting in the data. So I'm going to go to edit here, hit either enter or the number 1 key. And I'm going to put in the data that we just saw. So 8 and then enter, and then 12, enter, and then 32 and then enter, and then 6 and then enter, and then 27 and then enter, and then 19 and enter, and 54 and enter. Okay, now if you're getting the 5-number summary with the calculator, you don't need to sort the data. However, I'm going to sort the data here so I can show you something about the quartiles when we get there. So I'm going to take a little extra step right here, and I'm going to sort the data. So stat, sort ascending. Remember, sort ascending sorts the data from the lowest value to the highest value present. So I'm going to hit number 2 and hit enter. I'm going to specify that I want to sort L1. So second, number 1 here, and close parenthesis and enter. Okay, tells me it's done. I go back and I'm going to look at the list just so I can rewrite this. I'm going to take another note right now, and I'm going to use this in just a moment. 6, 8, 12, 19, 27, 32, and 54. Okay. And as we can see, there are 7 values. Now, if I want the 5-number summary of this data, whether it's sorted or not, doesn't matter. The 5-number summary that we saw, the minimum, the quartiles, the maximum, we get from stat, and then we go to calc, and we go to 1var stats, which if you've seen some of my other videos, you know some of what 1var stat can do. So let me show you that. Again, this is ungrouped data, so we don't need a frequency list, and L1 is already there. So I'm going to calculate it. Now you've seen me talk about these options up top, the mean, the sum of X, the sum of the squares, and the 2 standard deviations, the one for the sample and the one for the population and the number of values. But you see how there's an arrow pointing down and you see this blinking cursor? Turns out if you use your down arrow key, there's more stuff down here. In fact, there are 5 other values, and those 5 values happen to be your 5-number summary. The minimum X is 6. That's your minimum in your list. The first quartile is 8. The median is 19. The third quartile is 32, and the maximum is 54. Now, those are my 5-number summary, which I got from the calculator. So I'm going to write it. Minimum X, because I'm going to need this. Min X is 6. Q1 is 8. And median is the same as Q2, if you're wondering. So when you see median, the median and Q2 are the same thing. That's 19. Q3 is 32. And the max is 54. So now I can use that information to draw a box plot. So let me come over here and take a digression for a moment and show you a couple of things on the whiteboard here. Make sure that I'm actually sharing the whiteboard properly. Yes. Okay. So now, if you recall, this is problem one. Okay. Problem one. So here I started with, start with your starting data, which was 8, 12. This is what I was writing on the notes that I told you I was writing next to me. I want you to have the same access to it so you can see what's going on here. 27, 19, and 54. Okay. Now, and we sort the data, sort to get the same list, but in a different order. 6, 8, 12, 19, 27, 32, and 54. Now, the reason that I wanted to go over this actually you could do by hand fairly easily. And this is by design. We want you to do it with the calculator, but having a smaller data set allows you to see what's going on. So we sorted the data. The 5-number summary that we're going to need for our box plot came from the calculator this way. So the 5-number summary was as follows. Minimum was 6, which we can see from the list. It's the smallest one. Q1, quartile 1, is Q1 was 8. Q2, or the median, was 19. So this Q2, or my median. Let me make a note here. Median, median was 19. Then Q3 was 32. And my maximum was 54. Okay. Now, here we want to find just the 5-number summary in the interquartile range. I'm going to go ahead and draw the box plot to show you what's going on. But this is the 5-number summary. The interquartile range, this is your large vocabulary word for the day. The interquartile range, we abbreviate this with the letters IQR for the first letter of each word. Inter, or each syllable. Interquartile range, okay, IQR. That's always Q3 minus Q1, okay? Q3 minus Q1, always. Okay, so that's how you get the interquartile range. So in this case, Q3 is 32 and Q1 is 8. 32 minus 8 is 24. So we have the 5-number summary, we have the interquartile range. That's how you get the end. Now, when you want to actually draw the box plot, yes, your calculator can do this for you. I'm going to do it for you by hand on this small data set and then show you how to do it with the calculator. But what we're going to do here, I'm going to start by drawing a straight line on the bottom of your paper. It doesn't have to be huge, but do make it large enough so that you don't have to squish everything. The more data you have, probably make it a little bit longer. We don't have a lot of data here, or the larger span that we have. So somewhere above we want to scale our axis. And this is always tough for students. How do we know what to scale? Well, you take a look at your lowest number, which is 6. You take a look at 54. You know you have to get 6 in your range, and you know you have to get 54 in there. So you want to start, especially if you're graphing it, but on the calculator as well. Don't start right at 6, or it will cut off right at the edge of your box plot. You won't be able to see it. So maybe start this at, I would suggest starting it at 0 for this case. Sometimes you may start it at 10 or some other number, but I'm going to go ahead and start this at 0. And I need to go past 54. Remember, 54 is going to be my edge. So I might go here to 60. Now you could choose a different scale, as long as you can show all the values. So I'm going to go from 0 to 60 here. Okay. So I'm going to put 60 on the end here. And I'm going to label that. This is 60 here. Now, don't automatically start drawing your box plot yet, but do put in your tick marks. I'm going to scale this by 10 units, which means I'm going to count by tens. So I'm going to go ahead now and put in some hash marks for my, so here's my middle, right? Which my box plot may or may not be in the middle of, okay? So just keep that in mind. And I split this in thirds. So I'm going to do that and maybe do here. Okay. So I've got something like this and something like this. Okay. This may not be exact. You'll have a graph paper if you're doing this, or you can use a ruler to make this a little more. Try to make them look as uniform as possible. We're not all that sticky with that, but do try to make them look somewhat uniform. Okay. This is 10 unit. This is 20 units. This is 30 units. This is 40 units. This is 50. Okay. Now, just before, okay, so it would look something like this. Now we don't have a y-axis with a box plot, but what we do have is a rectangle. Okay. And if you remember, let me do a couple of things here. I'm going to switch screen. I'm going to go to the homework here. Okay. It just says find the 5-number summary in the interquartile range. It doesn't ask me to draw a box plot. So I'm doing extra work here, but I'm doing it for a reason. So for 1 through 3, you're only going to do this. So this part for 1 through 3, you're only going to do this piece of your of your, and I need the other drawing tool. Let me undo that and go here. You're only going to need, for the first 3 problems, you're going to find the 5-number summary in the interquartile range. But you don't have a y-axis when you draw a box plot. What you do is you find, let me get some color in here. Let me use green, okay? You're going to have a minimum at 6. So if this is your halfway point, if this is 5, 6 might be right here. Right here, put a point where your minimum is. And you can start a little bit further down. You want to start up from your axis a bit because you want to be able to make the rectangle, okay? And you can label this point so that you know, okay, that's 6. Now, your quartile 1 is where the edge of your rectangle will start. So somewhere here, I have another dot. I'm going to make it this rust color. And somewhere here, I have a dot at 8. So I'm going to go to my same, if I can get my pen to cooperate. Okay, I'm going to go to the same level and I'm going to come over just a bit and I'm going to put another dot right here. And this dot, and I don't want that dot to be green, so I'm going to change it to red. Okay, that dot, this is 8. Okay, so I'm going to put 8. I'm going to put it below it, I think. You'll see why in a minute. So this is 8, okay? And I'm going to erase this dot. Let's see. Erase this number, I should say. Put it down here. So then I'm going to say, okay, well, all right. So I know that. Now, that's where my rectangle starts. So what I'm going to do now, so I'm going to draw a rectangle, and you need, people say, well, how long do I make it? You make it decent size so you can actually see the features and maybe write within the space if you need to. Sometimes we need to put something there. So I'm going to go ahead and right here, I'm going to make my fence. Okay, this is 8. And I'm going to, how long do I make it? That's what this is for. It ends at Q3. So our rectangle ends at Q3. So I'm going to continue this line here all the way out to about there. Maybe there, okay? And I'm going to make this a little lower because, whoops, not that far. So I can attach it to the other side of my, okay. Now this part of my rectangle right here, this side of it is 32. This is 32. So I'm going to make a note here among the text box and write 32 there. Okay, this is 32. Now, this span, this length of this rectangle is my IQR, and it's where 75% of my distribution values lie. Okay, now you'll notice that there's a little space between, let me put another dot here. Let me use orange. So there's a dot, just like there was a dot for 6, there's a dot for 32. I'm going to put it at the same level so that we can actually see it. This is when you're actually drawing your box plot. So this is 32 right here. Okay. So that's 32. Now, this is 8, this is 32. There's a little space between your first quartile, sorry, and your minimum. So that little piece, we have a little whisker to the left. And we make a little line to show that we have a little whisker. Now we also have a maximum. Our maximum is 54. So somewhere out here, almost in the middle, I'm going to make another point. Okay. This point is 54. Now, that's my max. This is 54 here. Okay. Now I have a longer whisker out here. Okay. So I have a longer whisker here. So I'm going to draw my whisker from my third quartile. And we usually draw this from the center of the side to here. Now, if you notice something, this whisker is a lot longer than this whisker. That's okay. Sometimes they're equal, sometimes they aren't. Okay. But this tells us that this distribution might have an outlier. We would have to go through and check that. But this certainly looks like this is being pulled away from the center. Okay. Now you don't need to draw this box plot as part of your exercise for the first 3, but we do draw box plots later. I just wanted to show you what this looks like. Now your median would be 19. So remember I said that sometimes the median is right in the center and sometimes it's not. This is a case where here's our median somewhere here where the pink line is. Let me find my cursor. There it is. It seems to be wandering, lost and confused. Okay, 19, right about here. So it's not, your median is to the left, your center of your box is going to be to the right. So this is a skewed distribution. It's skewed to the right. It's being skewed by that 54. It's being pushed over. But that's what this is. So for this particular problem, you were only asked to find the 5-number summary and the interquartile range. But if you're asked to draw a box plot or scale a box plot, what we mean by scale, when we get to that with the window setting, is what the X numbers are doing. And what we mean by median is the line that Q2 makes with your rectangle. It may or may not be the center line of your box, okay? So for numbers 1 through 3, just this first portion on the left. You do not have to draw a box plot for the first 3 problems, okay? Just the 5-number summary, the interquartile range. Now, what I will show you here, let me come back to the homework. Oops. Let me come back to it. Somebody asked about number 6, but before we get to that, for exercises 4 and 5, use each box plot. So they've given you a box plot. They've given you a scale to identify the maximum, the minimum, the median, the first quartile, the third quartile, the interquartile range. This is why I drew the box plot on number 1, so you could see it. Now, where is my minimum at? Well, my minimum here, let's look at number 4. All right, so let me annotate this. All right, so my minimum here will be where this black dot on the left is, which is 3 units. So my minimum here, my minimum is 3, okay? My first quartile, Q1, is where the left side of your rectangle is. So the left side of your rectangle here is at 5, all right? So I'm going to say that Q1 is 5. Q2 is the same as the median, remember? So Q2 is going to be, where I'm now. Don't worry that it's not in the middle. If it's not in the middle of the box, it means that your distribution is skewed, okay? This distribution is skewed the other direction from because our middle of the box would be around 7, right? That would be our middle, but our median is actually 8. So it's pushed over. That's 8, okay? Q3 is the right side of your rectangle. So Q3 here is going to be 9. So Q3 is equal to 9. Your and just for completeness, your max, which they didn't ask for, the max is 11, okay? Max is 11. Now remember, my interquartile range is always Q3 minus Q1. So here, I'll put it underneath my interquartile range, my IQR, is going to be, it's going to be Q3 minus Q1. Okay. And that's going to equal 9, which is the right side of my rectangle. It's not your maximum. Be careful there. It's the right side of your rectangle, which is 9, minus the left side, which is 5. So 9 minus 5 is equal to 4. Okay. So in this case, here's your 5-number summary. Here's your IQR. Okay, for number 4. I'll let you do number 5 on your own. Okay. So the first 3 match number 1 that I did, number 4 and 5 match each other. And then the rest of them, 6 through 9, will be similar to what you're going to see me do next. So let me leave that there for a moment. You can screenshot it. You can do whatever you need to do. I'm going to clear the drawings from here so that I can scroll down and we can work on an actual box plot. I've given you everything I can in terms of preliminaries, in terms of prerequisite knowledge here. Let me get the mouse back. My mouse is not responding. There we go. All right, so now let's see. All right, number 6 is the one that somebody had a question on. So it said, construct a box plot and comment on the shape of the distribution representing the number of games pitched by Major League Baseball earned run average leaders for the past few years. So once again, I'm going to scribble the data down so that when I go to the calculator screen, I don't have to keep going back and forth with it. So this is 30. Okay. This is 30, 33, 34 twice, 29 and 27, 32 more times, 34 and 27, 29 and 34, 29, 34, 31 and 32. Okay. Now here I'm going to endeavor to put together all of the skills that we've seen in the previous problems. Okay, we're going to calculate it. We're going to see if it's symmetric. We're going to comment. We're going to see what we can do. So once again, I'm going to bring up our friend, the calculator. All right. And I'm going to go ahead and clear out my data from L1. So I'm going to stat, edit, and since I only have one list, I'm going to go up to L1 and use the clear enter shortcut to clear it. And I'm going to enter my data just as before. So here I have, this is 30, 33, 34 twice, then 29, 27, 30, 30, 34, 27, 29, 34, 31, and 32. And once again, I'm going to sort the data just as I did before. Stat, sort A, okay, specify L1, second L1, and close, enter. Go back to my sorted data, stat, okay. Edit. Now, here I'm going to, you'll have to draw this on your paper. I'm going to show you how to draw this on the screen. And then I'm going to go back to the whiteboard and comment on something here. So we can see that our minimum, oh, I should point out, let me do something here. So my, let me go and get the 5-number summary for you. So 1 var stat, L1, calculate it. Remember, go down to see your 5-number summary. Here it is. Okay. So my 5-number summary for this data is I have 14 data. I have a minimum of 27. So I have a minimum of 27. I have a first quartile of 29. I have a median of 30 and a half. Median 30 and a half. Okay. Your third quartile of 34. So I'm going to make a note there. And a maximum of 34. Now, somebody commented and said, how is it possible for my third quartile and my maximum to be the same? And that's because the 34 is repeated. If I show you something. Let me draw the box plot first for you. So what I'm going to do is go to the window, and we're going to do something similar to what I did on the whiteboard within the calculator. My minimum is 27, remember. But here I want to set the minimum lower, obviously, than the minimum I have. If I set my minimum at 27, and I set my maximum at 34, and let's say I scaled this by 1 unit, okay? If I graph this thing, I'm going to go to my stat plot, second stat plot. Make sure your plot is on, okay? If it happens to be off, hit your enter key. You can toggle it. Sometimes it will be off. Make sure it's on. Make sure that the first box plot command is selected, and tell it which mark you want. Go ahead and graph it. And it looks, oops, I think, hold on. Yeah, what you can see here is you've got a really long whisker on the left, but it's hard to see it because of the way you set the window. So if I move this window setting to say 10, now if I graph it and I move my maximum to say 40, right? And I scale this by 5. So I'm going basically 10, 15, 20, 25, 30, 35, 40. Watch what happens now. Now I get a much better picture of, whoops, I meant to do that. There we go. I get a much better picture. This is a little bit spottier because the scale is a little bit wider, but you can still see long whisker here, right? But this, that you don't have a whisker over here. You don't even have a maximum. Why? Because that 34 is repeating itself, okay? This distribution, you can see that we're going to calculate the mid-quartile for this data, but you can see that you have skewed distribution here, all right? So let's go back to the whiteboard and see what's going on with some of this data. I'm going to start edit first. I'm going to go and look at my list and plug in. I'm going to put it on the whiteboard so we can see what's actually going on with our data. So I have 14 pieces of data, and I have 27 twice. So I have 27, and I have 29 a couple of times, and I have 30, and I have, so there's 30 down there. I have 31, 32, 31, 32. I have 33. And I have 34, 1, 2, 3, 4 times. That's what's happening. That's what's giving us such a strange result. Let me show you what we're doing here. So there's my data. Let me go to the whiteboard and see if I can answer this for you. So we're going to construct another box plot. We saw it on the calculator. We're going to see this. This is problem 6, okay? So let's remind ourselves. Problem 6, let me make this black. There we go. Problem 6, all right? So our data set, all right? I'm gonna copy our sorted data, all right? So it was 27, 27, 29, 29, 30, 30 3 times. Then 31, 32, 31, 32, 34 3 times, or 4 times actually. 31, 32, 34, 34, 34, and one more, 34. Now, if I do obviously we can see the minimum, the maximum pretty easily. Think about how I do the median here, okay? If I were to do the median by hand, okay, and this is another point that I wanted to bring up. The median is not on this list. Let me show you why. Here, n is 14. Okay, there are 14 pieces of data. That means that we're going to have a middle number between two numbers. Whenever you have an an even number of data points, you always have a median that requires that you add two numbers together. So here, if you think about it, I'm going to cross out one, cross out another one at the bottom. So this is, let me do this without crossing them out. I'm going to put a line under it. So here we cross this one out, cross this one out, then we cross out one on the bottom. So we cross out 27, cross out 34. We cross out 29. We cross out 34. We cross out 29. We cross out 34. You see all the 34s go away. And we end up with these two, oops, we end up, I made them an error there. 1, 2, 3, 4, 5, 6. There should be 6 numbers on each side. Hold on, I crossed out one too many. Whoops, undo that. I just need to erase this. So here we have this 30, okay? So what happened is when I go back, let me erase this. Let me try this one more time. Okay, this is, I'm looking at this 7.5 spot. So 1, 2, 3, 4, 5, 6, 7.5. So I'm looking at this, and I'll do the count for you right now. One more time. I'm looking at averaging those two because I crossed out that. So I have 2 of these here, okay? Now, if you don't want to do the crossouts, she wants to see the formula, but that was one question. So it is possible, your location, remember, is n plus 1 divided by 2. Remember that from the previous section that we did. So n plus 1 divided by 2, right? And this is going to be 15. So 14 plus 1 divided by 2, right? And so this is going to be, this is going to equal 15 divided by 2, which is 7.5. Now that's your location, but remember this is 30 plus 31. And remember, when you put this in the calculator, you're going to use your parenthesis, divide by 2. This is 30.5. So it is possible that your median may be a value that is not in your data set. So if that becomes a true false question, that's true. Is it true that a median may be not in your data? Yes, it can be, but it may not be. So that's this. Now, why is it that your third quartile and your max are the same number? Well, if I'm looking at the third quartile, my median is here. So my median is, let me write this in. So my median, I'm going to write it in green. Okay. My median is right here. It's 30.5. So I'm going to put down here, put this in green. This is 30.5. Now, if I look at to calculate my third quartile, I have to look at the number of values that are above that green 30.5. So I'm going to go from this 31 to this 34. And I'm going to look at the median of those values. So I'm going to look at 31, 32, 34, 34, 34, 34. If you look at the median of those values, and I'll underline them in green. Let me draw in green here. Let me just draw in green. Okay. Then I'm going to start at the beginning and I'm going to cross out. I'll put it above it this time. Cross out this 31, cross out this 34, cross out this 32, cross out this 34. Now I have two middle numbers here, and 34 and 34 divided by 2 would give me 34. This is Q3. Q3 is right in the middle of these values that give me 34. That's why this 34 is repeated. It's not something that you have to be too wary of, because the calculator does give you that. But somebody did ask me, and that's the reason why this 34 repeats so much, because your quartile is right in the middle of that. You can see from, I'll go back to the picture on the calculator right now, so we can look at your box plot. But that's the reason why your third quartile and your maximum are repeated, as somebody asked for this data. So let me go back to the calculator screen here. Let me go to the graph, and we can see that our median is to the left of center. Now, where's the center? Okay, let's look at the center. That's something that I did not show you here. So let me put in so we have your mid quartile. It's not the median, okay? This is the middle of the quartiles, Q1 plus Q3, okay? We're going to divide that by 2. That's going to give me, now, Q1, remember, was, let me go back. Q1, I'll give you the data. Let me put it over here. My minimum, because I didn't give you the 5-number summary, my minimum was 27. My Q1 was 29. Yes, 29. We spent a lot of time talking about Q2. So Q2, or the median, was 30.5. Q3 was 34, and your max was also 34. So let's do some calculations here. Your mid quartile was Q1, which is 29, plus Q3, which is 34. 29 plus 34 divided by 2. Okay. If you take 29 plus 34, that's 63. 63 divided by 2 is 31 and a half. Okay, 31.5. Now, your mid quartile is 31 and a half. Your median, remember Q2, was 30 and a half. So your median is 30 and a half. Okay, so it's over to the right. Now let's take one quick look at the slides for a moment here. Let me, oops, I didn't mean to bring up the chat. Let me take a quick look at the slides. New share. Here's our slides for this. And we want to look at what happens when we have now here. If the center is near the median of the box, the distribution is approximately symmetric. If the center, which for us, remember, is 31 and a half, falls to the right of the median, which ours does, the distribution is positively skewed. So the center, 31 and a half, is to the right of 30 and a half. If I show you one more time, here is the box plot. Okay, this center, okay, our center is going to fall, our mid quartile is going to fall to the right of this. So what we would say after we draw our box plot, we would say this. We would say that we can say that since the center of the box is to the right of the median, the distribution is positively skewed. Okay, and then you would go ahead and draw the same thing that's on your calculator with the values that we've used before. So the other thing we want to do is we want to check for outliers. Okay, so what we do with that is we need the interquartile range. So we know how to get the interquartile range. That's 34. So this is my IQR, right? My IQR is 34 minus, because remember it's Q3 minus Q1, 34 minus 29, which is 5 units, okay? Then you take, now let's go to another procedure here. To find your outliers, you're going to, if there are any, we'll see if there are. We're finding outliers, okay? Finding outliers. So we have your minimum, your X minimum. your outlier, your interquartile range, your IQR from the previous page is 34 minus 29, right? Which is 5 units. Now, you're going to take your IQR and you're going to multiply that by 1.5. Okay, so we're going to take your IQR, going to multiply the IQR by 1.5. 1.5 times the IQR means that you're going to have 1.5 times 5, which is 7.5. Okay, that's going to be 7.5 units. Now, to get your upper and lower limits, we call them the fences. We're going to call this let's do the lower boundary. We're going to take Q1. Your lower boundary has to be smaller than the left side of the rectangle, okay? Your lower boundary is Q1 minus this answer that you just got, 1.5 times the IQR. Okay, 1.5 times the IQR. All right. So then you get your lower boundary is going to be 27, because that's your Q1 was, if you go back, you can see Q1 was 29. My apologies. So this is 29. Let me fix this. Oopsie. Let me do this. Let me cross this out. It's not 27, it's 29. It's 29. I mistyped that. This is 29 minus 29 minus the 7.5 units. Okay. And similarly, my upper boundary, so 29 plus 7.5 is 36.5 units. Okay. There's nothing in my data set that's higher than 36.5. Our max was 34. So I don't have any, excuse me, I just subtracted when I should have added. Sorry. I mean, I added when I should have subtracted. My apologies. 29 minus 7.5 is, let's see, 29 minus 8 would be 21. So it should be 21.5. This is 21.5. 21.5. I don't have any values lower in my data set. Remember, my lowest is 21. So I don't have any outliers in this data set. Let me show you why. My upper boundary, which I accidentally gave you, is equal to my third quartile, which is 34, plus, so this is Q3 plus 1.5 times the IQR, okay? And this data, this is going to be 34. So my upper boundary here, my upper boundary is going to be 34 plus 7.5, 1.5 times my IQR, and that is 41.5. Okay, that is going to equal 41.5 units. Now, as far as outliers go, do I have any data values? So what I ask myself is, are any values in my data smaller than this lower boundary? The answer is no, because my minimum was 27. Are there any values? Are any values larger than, are any values in my data larger than this one? They're not larger than 41.5, so no. And because the answer to both of those questions is no, I can say that my data set, even though it's skewed, my data set has no outliers. Since there are no values smaller than 21.5 or larger than 41.5. It is skewed. It is positively skewed, as we saw, but there are no outliers. I hope that this helps you, and I look forward to seeing you in my next video. Thanks for sticking around, folks. I know this was quite a recording.